Ooh, a bouncing ball. So we're on miscellaneous questions. If you've heard this already, get what you can out of the videos. Pause when you need to. I'm going to run through answering the question. So as soon as you get something a little step further, pause, jump out the video as need be. So a rubber ball is dropped from a height of 40 centimeters. Hey, that's quite cool. Imagine that. Here's our rubber ball, and it's gone wee down by 40 centimeters. Oh, the excitement. Each successive bounce, it loses 25% of its height. So it's bouncing straight back up, but I'm just going to show that over here so it's not right on top of it. And it's going up, and it's losing 25% of its height. So if the first bounce here was 40, the next bounce that it goes up is only 75% of the 40. In other words, 3/4 of 40. Well, if you either work that out in your head or in the calculator, then 75% of 40 is 30. So it's gone up by 30. Then it's going to drop back down again. Well, by the same amount, right? Because it has to get back down to this ground. And then it's going to jump and bounce up. Oh, let's get this to a perfect scale. There's 3/4 over there. And it's only going to go up 3/4 of 30. Well, 3/4 of 30, if we really want to work it out, we get, well, let me just show that, because 75% of the previous bounce, and we don't need to show this, but, you know, interesting enough. So 75% of 30, well, that's 22.5. And so the bouncing ball is going to carry on. Presumably it's going straight up and down, but maybe it's like parabolaing. I don't think that's a thing. Along, and it's going to go up, down, and eventually, after an infinite number of amount of time, it will be at rest. They're good questions about this infinity and giving something a context, but, you know, there we go. Bounce, bounce, bounce. We can get the story. Now let's turn this into a sequence. So we've got the 40 over here, plus each of these over here. Each time it's going up and down. The way I see it, and there are a couple of ways to do this, the way I see this is that, well, it's going twice this geometric progression. So twice 30 plus 22.5 plus. So this geometric progression that I'm talking about is the 30 plus the 22.5 plus, and it's going to keep doing that forever and a day. So in this geometric progression, we know that the first term is 30, and we know that the common ratio is 22.5 over 30. Well, that's the 75% we're given right at the beginning, which I'm going to write as a nice neat fraction, 3/4. So if we want to work out the total bounce, it's 40 plus 2 times this sum to infinity. Right? So we've got 40 plus 2 times a over 1 minus r, which we can just punch in the calculator and we'll get an answer of 280. Whatever the units were, meters, centimeters, doesn't really matter, centimeters. Okay, so that I think is a useful way just to kind of picture what's going on. 40, well, there it is, plus the 30 plus 22, but that whole geometric sequence is doubled. And I'm pausing on that to say you might have seen it differently, and you may have wanted to set this geometric sequence up as 60 plus 45 plus etc. And you obviously would have got the same answer. Either one, I don't know, 6 of one, half a dozen of the other. See you in the next one.